All right, for day one is inequalities. Um, the next slide that I showed you is very important. I make sure you write it out. It is very important pertaining to inequalities because you know most of these except for two new ones. So we're going to test to see if numbers that I give you actually are solutions to the inequality. So an inequality has more than one answer that could be equal to, and then again, determining if the inequality is true or false. Tomorrow we'll look at writing them and graphing them, which again, you'll just have to select the correct graph since we're virtual, but same idea here. So the inequalities you are familiar with are the first two. Inequalities are basically a mathematical sentence that tells you basically things are not equal, okay? However, now that we have something like this, well, the first one here is a less than symbol. So it would kind of be something like this where 2 is less than 3. So in this symbol, you usually say less than, or sometimes maybe fewer than. Something, okay? Where we're looking at now that we're kind of towards like the more algebraic-y type stuff, it would look then like something is less than 3. So this something could be any number less than 3, but not 3. That's a lot of numbers, okay? Same thing here. If I have then flipping this around, let's say I have 4 is greater than 3, right? 4 is greater than 3. So we say this as greater than or more than. My handwriting is horrible. Again, now that we're looking at more the algebraic way of thinking of that, let's replace x with 4. So x has to be bigger than 3 in this example. So any number bigger than 3, but not equal to 3. So these are the two new ones. Same thing, but if you notice, the symbol now has this little bar below it. And that bar below it means that it is less than or equal to. Same thing you could say as fewer than, or it can also be equal to it. So for instance, I could do like, 2 is less than 3, but whereas this one, it couldn't equal 3, but this one now can equal 3. So then in this case, it would look like this. The only difference between this one and this one is this one is not allowed to be 3, but this one is allowed to be 3. That was like really bad. So that's the difference between those two. It includes all the numbers lower than 3 and also including 3. Okay. Same thing here, same applies. Whether it is greater than, so again, 4 is greater than, let's say for instance now, I don't know, 2. Just switch it up, okay? Actually, no, let's do the 3 because that's like the other one. 4 is greater than or equal to 3. So same thing, it's greater than or equal to. You can replace it then with more than or equal to. So if I replace the 4 with an x, x is greater than or equal to 3. Again, this one is allowed to equal 3, whereas this one is not allowed to equal 3. Okay. Last thing, and I'm just going to have you put it here, is when we start to graph, when we are graphing, just keep this in mind. Open circle, close circle, close circle. The reason why these are closed is because it's allowed to include that number, like that dot. Whereas these ones are not allowed to include that number. so that's why it's open, but I'll explain that more in detail, obviously, in the next lesson. But might as well write it here since you wrote all that other stuff down. Okay? So let's look at some examples. Again, it's very easy. However, think about you reading this sentence from left to right. And that's where kids get messed up all the time here. So if I look at here, of the numbers, 9, 10, 11, which is a solution to an inequality? It could be one of them, it could be all of them, it could be none of them. So you just got to be careful about how you do it. So when you do this, the best way I can tell you is to write the inequality down. And then plug in, this is n, and then this is n, and then this is n, and read it left to right. You should be reading it from left to right. So if I look at this right here, if I plug in n is 9, right? 9 minus 3 is greater than 6. 6 is greater than 6. Is that a true statement? It is not greater than. So 9 is not going to be a solution. Then I do the same thing again. 10. 10 minus 3 is greater than 6. 10 minus 3 is 7. Is 7 greater than 6? Again, I'm reading it from left to right. That is true. 7 is greater than 6. So if 7 is greater than 6, then you should assume, by using, logical thinking here, if 10 is going to work, then 11 should work, because again, it's bigger than 10. So if 10's working, 11 should work. So if I do 11 minus 3 greater than 6, 8 is greater than 6. And again, that one is true. So which ones are solutions? Only 10 and 11. Okay. I'm telling you to write it out because you're going to rush and you're not going to read it correctly. I've been doing this a long time. Do what I'm telling you. Okay. So same thing with this one. Kids get this one wrong all the time because they are not reading it correctly. So let's look at here. Again, this one didn't have that bar underneath, so it couldn't be equal to. Since this didn't have this little symbol right here, if it did, then I would have selected this one, but it didn't have that. So let's look at this one here. So all we're doing is just plug it in. I have 20 is greater than or equal to 2y. Now we know that this is 2 times y. Which of the following is solution? So I'm going to place this in for y, y, and y. Okay. So I'm going to write it out. 20, 2 times 8. 20 greater than or equal to 2 times 8 is 16. You have to read it from left to right. Now, if you read the other way, you just have to then think about reading the symbol backwards. So just read from left to right. It's going to save you a lot of headache. Okay. So is 20 greater than or equal to 16? Yes, it is greater than. It's just not equal to, but it still works. Okay. Do it again. 20 greater than or equal to 2 times 9. 20 greater than or equal to 18. Is that true? Is 20 bigger than 18? Yes, but it's not equal to, but there has to be one of those. So if I'm reading it this way, this is also going to work. Look at the next one. 20, 2 times 10. 20 greater than or equal to 20. So the reason why this is also true is 20 greater than 20? No, but it is equal to. So that's why all 3 of these work, because it has this equal sign here. That means that is, even though 20 is not greater than 20, but it also means that 20 can also equal 20. So this one is a true statement. Again, read it left to right. If you don't do that, you're going to make a mistake. Okay, continue on the process. If you need more examples, feel free to ask me. But you can go ahead and skip over this if you understand the concept. If you don't, go ahead and pause the video, see if you get the same answers. So, Okay, so answers here are as follows. The reason why this middle one on the second one works because it says it's equal to. So again, make sure you're reading from left to right. Okay, so at this point, if you're at here, again, this is good test taking skills. Literally, just plug them in, and then once you get to a part where it's a no, or where you get to a part where it's yes, it should be all the numbers either bigger than that or all the numbers lower than that. So let me show you what I mean by that. So this is saying a plus 7 is greater than or equal to 15. So I'm just going to put plus 7, plus 7, plus 7, plus 7, plus 7, greater than or equal to 15. Okay. I look at this. I go, okay, this is 13. 13 is not bigger than 15, so it's not that one. This one is 14. 14 is not bigger than that. This is 15. 15 is not bigger than 15. However, because it has this one, it is this one. And because that one works, anything larger than that should also work, because that's kind of that threshold whether it's going to work or not. So by the way, these ones would also work because these are all numbers bigger than 8. All numbers that are 8 or lower than 8 weren't working. All the numbers then, if 8's going to work, then that means any numbers bigger than that should work. And it does, because this would be 16 and this would be 17, and those are larger. Good strategy. Now, for this one, be careful because the order does matter here. I'm asking you is, so if I was going to do this one, 5 is greater than half of x, so half of 6, but I have to read it the way that I'm saying it. If you're going to flip stuff around, you're going to make a mistake. Is 5 greater than half of 6 is 3? Is 5 greater than 3? Yes, but if you decide to flip that around, you can flip it around as long as you flip your sign. You can flip it around if you want the variable on the left-hand side, but you have to flip the sign around. Otherwise, you're saying the wrong statement. So I'm going to read it as specifically the way it says. So this one, yes, is true, because 5 is greater than 3. If I take 5 and I take greater than half of 8, is 5 greater than 4, because half of 8 is 4. That is also true. So if I plug in 10, 5 greater than half of 10. Well, half of 10 is 5. Is 5 greater than 5? No, unless there was an equal sign or that little bar at the bottom, it's not. So if basically this one's not working, anything bigger than that should not work because that's that threshold. So again, if it has the line, that means it can equal that number. If it doesn't, then you're not selecting the one where it's equal. So again, right here, this is not a true statement. So if you ever see somebody put a line through the sign, that means it's not working. Again, kids get this one wrong because they're reading it wrong. So read it from left to right, plug it in, write it out, do it correctly. Because if you miss one of these, we're going to mark it wrong. It's either 1 point, or no points. There's not partial credit for these. So either you're getting the concept or you're not. Okay, same thing here, plugging in, getting your answer. So feel free if you want to pause it, great. Or if you want to move on, you can go ahead and go to the next part here. So if you want extra examples, here you go. You can try these. So you can pause the video if you want. Okay, so you got those answers, you did it correctly. Last one doesn't work because 22 is not less than 21. All right, so last thing, just a couple of problems where there's word problems, but really honestly, it's already telling you what the inequality is. We are going to get to the part where we are also writing the inequality. So I want you to kind of pay attention, a little bit more detail, because this kind of hints at the next assignment. So let's say, for instance, if we're at a bakery, they sell, if the bakery sells more than 45 bagels in a day, basically they're making money. So they have to basically sell 45 to be starting to make some money. Okay, so see where it says more than 45? Use the inequality, B greater than 45, B meaning the number of bagels sold, in order to determine which days they are making a profit. So more than 45, we're going to get to this part where we're going to write the inequality. You should see now the relationship between that. So B greater than 45 are all the days that I'm going to select. So strategy, ask yourself B, because B's on this side, right? Not on the other side, it's on this side. This is my B's. I'm asking myself, is this greater than 45? No. 25 greater than 45? No. 21 greater than 45? No. No. Yes. Yes and no. No. So the only 2 days they are making a profit were on Friday and Saturday. All the other days they're not making any money. Okay, so looks like it's probably about how the world's working right now with some small businesses, right? So the answer to this question is, if I said select all that are true, you would have to select specifically Friday and Saturday. If you click anything else, it's going to mark it wrong. It's either 1 point or no points. Either you get it or you don't. Okay, next one. Again, same concept. I'm just trying to show you where this is coming from. So this is a type, like different types of roller coasters. So they decided they're going to build a new roller coaster. We got to make sure there's less than 10 or equal to that type, basically, for them to do it. You don't want to build more of the same type, right? You want to build something that's maybe not as popular. So if you look at here, less than or equal to 10, right? So that's where this is coming from, where R represents a number of a certain type of roller coaster. Determine which types can be built, like the ones that they want to build that are not popular, right? The ones that are not a lot of them. So if you look here, again, R is on the left-hand side, so assume that this is R. And then I'm just going to write it once, and anything that is a true statement to this, you could write it down. But I'm going to do it just because, to show you, any of those that are true are the ones that I need to select. I select one of them incorrectly, it's wrong. So let's look right here. It has to be true. Is 3 or 5:30 less than or equal to 10? No. 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 Yes, because it's equal to. Yes and yes. So which one should I be selecting? These 3. These ones are more than the 10. Okay, so there's your answer. That's all you're doing is just figuring out which ones are true. But again, pay attention to where's your variable. Okay, kids get this wrong all the time because they're not looking at it. Okay, so then sometimes I might have like a little sorting thing. So LeVar wants to buy new movies to add to his collection. He basically wants to buy movies that he has more than movies of the type. Use the inequality this, where M is the number of type, or number of the type of movie, to determine which types he can buy. So he only wants to buy movies where he has more than 15. Okay, so M is the number, has to be bigger than 15, not the other way around. So any of these are true. That's the category in which we want to put it in there. So is action going to be something he'd want to purchase more of? Correct. So that would be action here. Okay. Is 24 bigger than 14 or 15? Yes, it is. So he'd buy some comedy. Okay, drama. Nope. Won't buy drama. So drama is something he doesn't want to purchase. He's not liking the drama. And thriller, that's the one you have to determine. Is it equal to? It is not. So thriller would be something that he would not want to purchase more of. So again, be careful with your sign. You miss one of them, it's wrong. It's either right or wrong. Okay? Same thing here. We can go from there. All right, so let's look at this one here. Let's say Leah can send, does it say no more than? Yeah, my face is over it. All right, so Leah can send no more than. So think about that. No more than 55 text messages in a month without being charged extra. Think about what that means. Without being charged an extra fee. Use the inequality. This T means the number of text messages sent, where she's basically, where she determine which month she will have to pay an extra charge. So she is not allowed to text more than 55 messages. We know that's not the situation anymore because we have unlimited, but let's, hypothetically speaking, no more than, think about this, and I'm not allowed to have no more than 30 kids in this class. Am I allowed to have 30? Yeah, I'm allowed to have 30. Can I have 31? No. But can I have 29? Yes. So that's why this one is less than or equal to. Because I'm allowed to have 55 without getting charged, but anything over that, I'm going to get charged. So let's see how which months hold true where she's going to get charged. Is 55 less or 56 less than 55? It is not. This month she's going to get charged. Is this true? Nope. She's going to get charged that month. Is this true? Yes. So she's not going to get charged. She's going to be safe that month. And she's also going to be safe this month without getting charged over. Okay. Now, so which months that she gets charged? She's going to get charged over on January and February. So this is now applying it to kind of the real world. If each additional text, so per text, each text, every text is 28 cents, then how much was Leah charged from January through April? So you just have to ask yourself, how many did she go over here? She only went over one text message here, and she only went over 2 text messages here. So she went over 3 texts. Well, if each text costs 28 cents, we can multiply by 28 or add 28 3 times. So how much did she get charged? 16, 6, 7, 8. Only 84 cents over. So not too bad. So the answer is, how much did she get charged? She got to get charged 84 cents. She went over. She went over what she was allowed. Okay, so it's also a matter of reading it, because I might ask you, tell me which ones are not true. Those are the ones I want you to tell me. So be careful to read the question. Other than that, guys, that's pretty much it. Okay, so hopefully that made some sense. And go ahead and start the assignment. Maybe not. Let's end the chat.